We've been looking at the variables in coffee extraction in some detail. It's time to put it all together to get an overview of the process and to see how the variables affect our coffee brew. Although there are other brewing methods like cold brew and vacuum brewing, we're just looking here at the three main brewing methods: immersion, drip, and pressure brewing using hot water. Immersion is where we soak the coffee grounds in water for the duration of the extraction. Examples are camp coffee, e-brick, cafetiere, aeropress, trifecta, steampunk, siphon, clever dripper, cupping, and filter bags. Drip is where the water pours through the grinds, extracting as it flows through. Examples are the V60, automatic drip, Milletta cone, Chemex, Phoenix, and ice drip. Pressure is similar to drip, but has 6 to 10 bar of pressure acting on top of the coffee. This is the espresso machine. The goal of each brewing method is to use water to extract coffee from the grinds, and to do that, we need to grind our coffee beans. The finer the grind size, the greater the surface area exposed to the water. The greater the surface area, the faster the extraction. All grinders produce a range of particle sizes, so even if we grind coarse, we still end up with a range of grind sizes, and the vast majority of the extraction comes from the dust that we call fines. We need to balance the high extraction from the fines with some interesting flavours from the coarser grinds. Immersion brewing typically uses larger grinds, resulting in more extraction from larger grinds relative to drip and pressure brewing. Drip brewing typically uses finer grinds than immersion brewing. The finer we grind, the slower the flow of water through the coffee bed, and the greater the contact time. Grinding too fine may restrict the flow of water through parts of the bed. Pressure brewing typically uses much finer grinds than immersion or drip brewing. Grinding for espresso creates many more fines than in immersion brewing and drip brewing. This, along with emulsified oils, gives espresso its heavy mouthfeel. Grinding finer does increase extraction, but there's a point where the flow rate is so slow that your extraction over time is going down instead of up. This is too fine. In summary, changing the grind size changes the surface area, which changes the rate of extraction. The dose is the weight of the coffee. We usually dose higher for immersion brewing than for drip or pressure brewing. This is because some water with the same concentration as our brew remains with the grinds in immersion brewing, whereas the water that extracts the coffee solids out of the grinds in drip and pressure brewing is always being replaced with fresh water. If you wanted to use a lower dose with immersion brewing, you could brew with slightly less water initially, and flush out some more of the solids with a second brewing. The greater the temperature of the water, the faster most compounds in coffee extract. Always preheat your preparation equipment to keep the temperature consistent. I prefer to use water straight off the boil, again for consistency's sake. For immersion brewing, we start off with our entire volume of water. The greater the volume of brew water, the longer it remains hot. For consistent brews, ensure that you always use the same amount of water. For this reason, I like to weigh the water out first and then add the coffee. For drip brewing, the temperature of the water drops considerably as it hits the coffee bed. Preheat the device and keep your brew water hot. Some baristas pour extra brew water at the end before removing the brewing vessel or cup. This keeps the temperature in the slurry hotter until the end. In pressure brewing, the higher the temperature of the water, the less green and acidic the coffee will be, and it will head towards more bitter and ashy. The brew ratio is the ratio of the coffee to water. We can measure the volume of the water using scales because 1 gram of water equals 1 milliliter. For immersion and drip brewing, the convention is to use the dry coffee grinds and the brew water to come up with a coffee-brew ratio. For espresso, it's usually difficult to measure the brew water. So we have the espresso brew ratio, which is the ratio of the dose to yield. We usually write the espresso brew ratio as multiples of the dose, i.e. 18 grams of coffee and 34.2 grams yield gives us an EBR of 1.9. As the water extracts coffee, it extracts in the order of the extraction spectrum. The start of the spectrum are the initial aromas. These are the fruity, floral, herby aromas. They are present in the first drop and are stored in the coffee lipids. Next are the fruit acids. These are acidic with citrus, tropical, and stone fruit aromas. They taste bright and crisp in sweeter brews and sour in less sweet ones. They dissolve very quickly. Caramels. The light caramels are very sweet and are followed by dark caramels, which are bittersweet. You should be trying to extract as many of these caramel flavors as possible. Maillard. These are the bready, woody, tannic or nutty flavors. Warm and comforting in sweeter brews, astringent in less sweet brews. They dissolve slower than the fruit acids, but will be present in all brews. The last compounds to extract are the dried distillates. These are carbonic, spicy, and terpene. They are bluntly bitter and ashy in less sweet brews, and have a bittersweet molasses taste in sweeter brews. They can be extracted early on, but are mostly extracted very late in the process. They are prominent in dark roasts. A weak extraction has more sour fruit acids, and a strong extraction has more of the dried distillate flavors. The flavors don't actually extract in this nice orderly fashion like 5 Britons queuing up for Devonshire tea. Rather, they all rush out of the grinds like rugby players emerging out of a messy ruck. The light and nimble ones tend to come out first, depending on who's collapsed on top of them, followed by the heavier players, and the massive props scrape themselves up last. However, for simplicity's sake, this is the rough order that they come out. For immersion, extraction is related to the contact time. The longer the water is in contact with the coffee grinds, the more coffee it extracts. The rate of extraction is slower over time. We stop the extraction by separating the grinds from the water. With drip coffee, we're effectively layering these flavors in the cup, and it's up to the barista to decide when the mix is right, and to either pour in that amount of water or pull the cup away from the pour. In pressure brewing, we have 2 phases to the extraction: pre-infusion and infusion. The espresso basket holes are 300 microns wide. Grinds less than 300 microns are permeable, that may pass through the filter. The longer these grinds remain in contact with the hot water during pre-infusion, the more they extract. The infusion phase starts when full pressure is applied. As the water pours through the puck, it extracts flavor compounds from the coffee and carries smaller grinds through the basket into the cup. The longer the pour, the more flavor extracts, and the higher the TDS. The yield, or beverage weight, is the weight of the liquid that arrives in our cup. The yield is less than the brew water because some water is retained in the grinds. The liquid retained ratio, LLR, is the ratio of water that stays behind in the grinds after we finish brewing. For immersion brewing, the LLR is around 2.5 to 1. That is, 2.5 grams of water is trapped in every 1 gram of what was dry coffee grinds. The liquid retained ratio for drip brewing is around 2.1 to 1. Espresso has much more force behind it, so the espresso puck only retains 1.2 grams of water per gram of coffee. Concentration. Concentration is the strength of the coffee measured in total dissolved solids, or TDS. That is the percentage of the solids for the weight of the brew. Using a preparation method that uses the immersion brewing method is usually pretty easy. Just weigh out the water, add the coffee, give it a stir and wait. The longer you wait, the more concentrated the water becomes. The extraction is rapid initially, but slows down, and it takes quite some time to extract the solids from inside the larger grinds. Drip brewing. Drip brewing is more complicated than immersion because where we pour the brew water and how we pour it introduces variables to our brewing. However, the fundamental difference with immersion brewing is that we are pouring fresh water through the coffee grinds, which means the more brew water, the greater the yield and the extraction, but the lower the concentration. We can see this relationship between yield, extraction and concentration by observing this graph of what we're getting in the serving vessel. When the yield starts to outpace the extraction, the concentration goes down. I use this cross-section of a gobstopper to illustrate extraction in the video The Relationship Between TDS, Brew Ratio and Extraction. All layers impart solids to the solvent, but each has a different flavour that it imparts. In our initial brew, we got a TDS of 1%. We can increase the TDS in immersion coffee by increasing the brew ratio, increasing the contact time, or increasing the surface area. Notice that, in this example, we increase the concentration of the brew from 1% TDS to 1.2% TDS in 4 ways that resulted in different flavours. With drip coffee, the same applies. If we start with the dose and the brew water, we end up with a yield with a certain percentage of dissolved solids, in this case 1.25%. And this coffee will have a certain flavour depending on the extraction. If we increase the dose and the brew water, maintaining the brew ratio, we should get increased yield with the same TDS and similar flavours as the flavour spectrum stretches out. To increase the concentration, we do the same as with immersion. We either increase the brew ratio or increase extraction. Although we have increased the TDS in all cases, the flavours are different. Increasing the TDS by increasing the brew ratio will make the brew more sour, and increasing the TDS by grinding finer makes the brew more bitter. It's the same story with espresso, just with more pressure. If you found that a bit complicated, that's because it is. Helpfully though, my mate Nick at Workshop D designed this poster to help you out. It's located at the end of this chapter, and a printable version is online.